G'day guys, Socket here. In today's tutorial we're going to take a look at how to make an SQ system loud. Now this is something that's been on the make list for quite a while. I think Barrett and Aaron and a couple of other guys have requested this, so apologies guys for taking so long to getting around to it, but we're finally going to answer that question today. So let's jump on in and take a look. So guys, how to make an SQ system sound loud? Well, it doesn't really matter whether it's an SQ system or an SPL system or what kind of system you have. The principles are still the same, and unfortunately there's nothing magic about it. To make your system loud, it's pretty simple, right? You need to send more power to your speakers so your speakers can create more sound energy. Right? The only trick is that the louder you want them to play, the tougher it gets. And that's why, you know, when the SPL guys have cars that look like this, that have a bunch of speakers and huge amps and things like that, you know, because they're trying to hit output levels of 130, you know, pushing 140 decibels. So, you know, it's pretty simple. More power plus more speakers equals a louder system. And as I said, that's why the SPL guys kind of look like this. But that's not the end of the story. I guess I better explain how it kind of all works and what you can do with your SQ system to get the best volume that you can out of it. Alrighty, so I just said that the louder you want it to play, the harder it gets. And what do I mean by that? Well, it's all to do with the power requirements, and the graph kind of looks like this, and you can see above a certain level, you know, it increases your power requirements to hit certain decibel levels, you know, go off the scale. So what do we mean? Well, a 10 dB rise in sound pressure level, right? So from 90 to 100 or 100 to 110, every 10 dB is twice as loud, you know, so 100 dB is twice as loud as 90, and 90 is twice as loud as 80, right? Kind of makes sense, right? Because the dB scale is not linear, it's logarithmic. Okay, so but for every 10 dB increase, a doubling of perceived loudness, you need 10 times the power. Okay, now for most people who listen, you know, around 80 or 90 decibels, you know, these power demands are pretty easy to deliver. But once you start pushing above 100 decibels, then the power requirement starts to increase exponentially. And this is one of the factors that limits how loud your system will play. But exactly how loud is 100 decibels? Well, it's pretty loud. It's equivalent to standing next to a speaker array at a rave or a nightclub loud, right? And do you really need it any louder than that? Maybe you want to push it, you know, to 110, which is twice as loud again. I don't know, but 110 should be, you know, more than enough. Then you want to, you know, even when you want to kind of send it, right? But I think people have this perception that you know, a system is not loud unless they're, you know, playing it at 120 or 130 decibels or something like that. You know, I think that there's a bit of a misconception about just how loud these decibel levels are. So let's take a quick look at that. Alright, so looking at the decibel scale. Now it all starts at 0 and, you know, makes its way up, and as I said, every 10 dB increase is a doubling in perceived, you know, loudness, right? So at 30 dB, which is normally the level of sound in your noise floor in your system, you know, that's like being in your bedroom at night, right? It's pretty quiet, right? Normal conversation is around 60 dB. Standing by a highway, you know, with traffic going by, is about 80 dB, and this is around about the level that most people sort of listen in their daily systems, and then it kind of gets louder from there, right? Now, you know, at 100, as I said before, it's like standing next to a speaker array at a nightclub or something like that, you know, and all the way up to if you've ever been to an air show and you listen to those jet aircraft, at 140 dB, I mean, it's just insane. Or, working with a chainsaw without hearing protection, 110. Now, most car audio systems, that we kind of play around with, you'll get to maybe 110 or 115 dB. And it really, when you've got it cranked up to those levels, it becomes uncomfortable to listen to. And when listening to, music at those levels, the pressure level that is being caused by your system is enough to actually damage your hearing, right? So to explain that, 85 dB is the safe threshold for hearing, right? And above that, it depends on how loud and how long you're exposed to, that sound level, right? So basically what happens is, between 90 and 110 dB, it becomes dangerous after being sort of in that environment for 30 minutes. So this is, cranking up your system pretty loud, listening to it, pretty loud for over 30 minutes. And that's certainly possible if you're, going for a long drive and you're, actually slamming the system. If you're listening to something at about 120 dB, which is the sound of a jet plane taking off, right? Being exposed for that for about 30 seconds will cause damage. And then, of course, above 130, 140 dB, even less, right? You can cause some pretty severe damage without wearing hearing protection, right? So, as I said, most of us will be listening to our car audio systems around 80, 85 dB, probably in the safe zone. Some of you like our systems a bit louder, probably, in that danger zone. So, you want to sort of think about how long and how loud you're listening to stuff. Most of our car audio systems will do 110, 115, maybe push into the 120 mark. It literally gets painful to hear or listen to stuff at that level. It's just uncomfortable and painful. So loud systems, around about 90 to 100 dB is usually plenty enough for most people, right? So just be aware that that you don't need your system to be playing 120 dB to sound loud. This is super loud at even 110, 100 to 110. Is more than you'll ever really need. And at those levels, you're causing damage to your ears. And what's happening is you have in your ears these hair-like receptors which are, move back and forth with the sound waves, right? And, just like any mechanical device, the louder the sound, the harder they're sort of pushed and pulled, like, trees in the wind. And up above that, that 90 dB and above, they get pushed and pulled beyond their limits, and that causes what we call the tip links and the synapse connections in those sensory receptors to get torn and ruptured, and that type of damage is permanent. So that's why loud sound levels can damage your hearing. So on that note, let's go and have a look at the science behind loudness and how we produce it in our car audio systems. Okay, well, let's start with this term decibel that we keep talking about. Well, decibel is named after Alexander Graham Bell, who was the inventor of the telephone, and it came from the days of early telephone communication where the engineers needed a measure of signal loss in telephone cables, right? So they created a unit of measure called the bell, right? And a bell is a 10 times increase in power. And so one bell is 10 times the increase in power, two bells is 100 times the increase in power. But these units were too big for sound engineering, so they created the term decibel, which is 1/10 of a bell. So that's where the term decibel comes from. So when we think about decibels in car audio, we think about sound pressure levels, right? But decibels are used in other fields of physics, and you have decibels in terms of millivolts and decibels in terms of full scale. So, we see this in our impulse response data when we switch from percentage to full scale. And so this is decibel full scale, which is the full scale for the maximum possible digital value. So there are lots of different places where the term decibel comes up, but for today we're only interested in decibels sound pressure levels, and yeah, that's what we'll talk about today. So a decibel is a comparative measure where we're measuring the subject, such as a voice or a speaker or a siren or something, versus the threshold of human hearing, which is the softest sound that you can hear with your ears. And we measure pressure in pascals, which is 1 Newton force over a square meter to be specific, but the threshold of hearing is 0.0002 pascals or 20 micropascals, which is an extremely small amount of pressure. So if you were measuring, for example, my voice, just talking like this, it might come out to be 0.02 pascals of pressure. I would plug that into the formula and it would give me an answer of 60 decibels, right? Which is about the level of normal conversation. So a decibel or a decibel measurement is simply a measure of how loud something is compared to the threshold of human hearing. So that's all really interesting, but how do we actually hear sound? Well, when we're talking about hearing sound, we're actually talking about our ears detecting those tiny fluctuations that are measured in pascals in the normal air pressure around us. So, when you're talking about air pressure, it is 100,000 pascals. So you might have heard on the news or the weather them talking about today's atmospheric pressure is 101 kilopascals or whatever it is. So that's the typical air pressure around us. And our threshold of hearing is 20 micropascals, a very small amount. But our ears can pick up pressure variations of 20 micropascals in amongst 100,000 pascals of air pressure, right? So we can detect sound pressure changes that are something like the order of 1 in 5 billion. And that is just absolutely staggering how sensitive our ears are to pressure change. So loudness is not about how much air that is moving, it's about the acoustical sound pressure wave that is traveling through the air that presses on our eardrums. Now, we covered how sound moves through air in the language of sound tutorial. If you haven't watched that already, feel free to jump back and check that out. So loudness is about the more acoustic energy that we create with a speaker, the higher the change in the air pressure in pascals, the more force that is applied to our eardrum, the louder it sounds. So the way that a speaker creates loud sound is by the distance that it oscillates in and out. Not how fast it moves, but how the X-max, how far it moves in and out. So if you want a 60 dB increase in loudness, you basically need to double the excursion of the speaker cone. So when we look at the decibel scale, we go from the threshold of hearing all the way up to the sound of a jet engine at 140 dB. This is 10 million times louder at this end of the scale than at this end of the scale, and we can see the relative loudness, right? So 10 million times as loud as this from 0 to 140 dB. It's a bit deceptive when we're looking at just decibel levels for what they are, because we do not measure decibel in linear, we measure them in logarithmic fashion, right? So the pressure variations increase logarithmically, as do the perceived sound also increases logarithmically. And as I said, the relationship before is, for every 10 decibel increase, we perceive it as a doubling in sound volume. So let's recap. So sound creates ripples or changes in the atmospheric air pressure around us, and it is this tiny variation in the air pressure that presses on our eardrums that allows us to hear sound. So if we want something to be louder, we don't need to move more air, we need to create more pressure, which means that we need to send more power to the speakers so that they move in and out with more force, which creates more acoustical energy, which creates a stronger pressure wave that exerts more pressure on our eardrum, and we perceive that as louder sound. And we measure the difference in the sound between the initial and the final compared to the threshold of human hearing in decibels. So pretty simple, right? But there are some common misconceptions that I just want to kind of clear up, because a lot of people say, oh, 6 dB is double the sound, or 3 dB means this, or 10 dB means that. Just to clear up any confusion, we need to talk about these very common myths. So the first one is 3 dB is a doubling in acoustic energy, not the doubling of sound. So acoustic energy is the energy that's produced by the speaker as a sound pressure wave, right? So this is how many watts of acoustical energy that your speaker is putting out. 6 dB, a 6 dB increase is a doubling of sound pressure. So this is measured in pascals. So we might go from 0.02 pascals to 0.04 pascals, and that would be a 6 dB increase in sound pressure level. And then a 10 dB increase in sound pressure level received by our ears is a doubling of perceived loudness, which we've already spoken about several times already. So 40 dB is twice as loud in terms of our hearing as 30 dB. But to increase the loudness, we have to increase the acoustical energy that we're producing from the speaker exponentially as we go from 3 dB to 6 dB to 10 dB. And so at 3 dB we need to double the acoustic energy, 6 dB 4 times, 10 dB 10 times the acoustic energy. So as you can imagine, pushing up the decibel scale requires more and more acoustic energy at a logarithmic which increases logarithmically. So there is this dynamic relationship between speaker output, the sound pressure that the speaker is creating, what we hear, how it's measured in decibels. So to really understand this topic, we need to dive into how these things work. So our speaker is moving in and out from fully extended to fully deflected, and it's creating pressure waves. But if we want that to be louder, we need to supply more volts and amps to the speaker so that the force at which the speaker moves back and forth, or the extension of the speaker cone will increase, because we're giving it more power, and it can work against the speaker's own internal resistance and all of that usual stuff, right? But how much power do we need to supply? Well, that really depends on the impedance of the speaker, whether it's a 2 ohm or 4 ohm or an 8 ohm speaker, and this speaker's efficiency. But let's just say that we want to produce 1 watt of acoustical energy from the speaker. We would probably need somewhere in the terms of 200 watts of power to go to the speaker. And you'd say, well, hang on, that what's going on there, right? Well, sending 200 watts of power from an amplifier to the speaker does not create 200 watts of acoustical power, because our car audio speakers are very inefficient. Tweeters are like 1%, 2% efficient, mid-range 3 to 5, mid-bass and subs, somewhere 0.1 to 0.3. These our speakers are not do not convert all the energy into sound energy. They have an efficiency rating. So giving 200 watts to our speakers does not result in 200 watts of acoustic energy. We basically produce 1 watt of sound, and the rest of the energy is converted into heat. So while we measure both power supply in watts and sound energy in watts, they are not the same thing. And there's this common misconception that if I send 50 watts from my amp to my speaker, that my speakers are playing 50 watts. That's not the way things work. We are actually looking at 2 different types of energy. One, we're looking at electrical energy, so 200 watts of electrical energy being created into 1 watt of acoustical energy, and the rest is lost as 199 watts of heat energy. So yeah, it's a very common misconception. So to get 1 watt of energy at our speakers, we typically need to put in somewhere between 50 and 1000 watts depending on the speaker's impedance and efficiency, right? But lucky for us, 1 watt is very loud. In fact, with a 4 ohm half a percent efficient speaker, 1 watt would be somewhere between 110 and 120 decibels, which is extremely loud. So once again, there's this misconception about exactly how much wattage our speakers are putting out in terms of acoustic energy. And I think that's because people are thinking about the electrical energy that we're putting into our speakers, like 200 watts or 500 watts, and there's this idea that our speakers are also producing 200 or 500 watts, and that's not the way it works at all. In fact, at daily listening levels like about 80 decibels or 85 decibels, we actually don't need much power at all. In fact, we're kind of only looking at zero point 0.2 of a pascal at 80 decibels and 0.0001 of a watt of acoustical energy. So tiny fractions of or microwatts of acoustic power for our listening at 80 decibels, right? So even at 100 decibels, we only need a fraction of a watt of acoustic energy, and so people will be going, well, what's going on? And that's because, as we just talked about before, a 1% efficient 4 ohm speaker, using 1 watt will produce 0.1 watt of acoustical energy, waste the rest as heat, but that amount of acoustical energy is enough to produce 100 decibels of sound level, right? So if we only need 1 watt to drive our speakers at 100 decibels, why do we need all of these massive 500 watt amplifiers for? Well, I'm glad you asked. Alright, well, the answer lies in this table, and I'll do my best to kind of explain it because it gets a little bit complicated, but bear with me. So in this column we have the decibel level, right, running from 60, 70, 80, and as we know, each 10 increase is a doubling in loudness. And then we have here the acoustic energy that is required to produce this sound pressure level, right? And we can see this also increases logarithmically, and with 1 watt of acoustic energy producing 120 decibels that we talked about a moment ago. Now, the next column is the electrical wattage that the amplifier will need to supply to the speaker to produce this acoustical energy to result in this decibel level, right? So at 120 decibels with 1 watt, we're going to need 100 watts of electricity or 100 watts of power from the amplifier, RMS, right? Not peak, but RMS. And so, if we have a look here, we're going to need 10 watts to produce 0.1 watt of acoustical energy, which will result in 110 decibels, right? And you can sort of see the figures here in the chart, right? So the example that we used before, looking at 100 decibels, there's our 1 watt of energy producing 0.01 of acoustic energy for 100 decibels, and the table goes on. But the problem is that this is RMS, right? This is your average root mean squared of your music playing, and that's not how life and music works. It's not one flat tone. We have peaks and dips and things. So to allow for a 15 dB headroom, right, to allow for peaks in the music, we also need to allow the wattages and power requirements to deal with peaks. And so this is fine for just playing, your average music, but when you get the peaks, you don't want them to clip, so you need enough power to cover that. So if we have a quick look at, let's say, the 100 decibels, we've got our system playing at 100 decibels, the amp is supplying, 1 watt of power, and, that is 2 volts and half an amp, just ticking along nicely, and then along comes a bunch of peaks in the music, cymbal clashes or whatever else, and all of a sudden we need to increase this by another 31 watts over the top of our 1 watt to deal with the peak, because it's a 15 dB peak that we're trying to deal with, and suddenly that 31 watts is needed by the amplifier, and our voltage jumps from 2 volts to 11 volts and from half an amp to 2.8 amps. Okay, not too bad. Most amplifiers will deal with something like that at 100 dB. But if you want your system to play at 110 dB, okay, well that's a little different. I'm going to be ticking along at 10 watts to supply this decibel level, and that's not too hard to deliver. That's 6 volts at 1.6 amps, but when I hit a peak, all of a sudden I'm going to want 300 watts of power, 35 volts at nearly 9 amps, right? And this is why you need big amplifiers, is not for your RMS supply, but to deal with the headroom that you need to deal with dynamic peaks in your system. And when you go up to 120, well, things get even tougher. You need 100 watts RMS ticking along all the time, and a peak of 3,100 watts. Okay, and this explains why when you get with the SPL guys, they have super huge amplifiers or banks of amplifiers and lots of speakers and things to create huge sound pressure levels, because the power demand to meet both RMS and for peaks is absolutely massive. So if we go back to that original chart that I put up right at the very beginning, this one here, we said that below 110 it's not too hard to deal with, but as soon as you get above that and into these areas, the power demands on your system and the size of amps and things that you need to get there are astronomical. And this is why manufacturers are able to make DSP amp combos, and small compact amplifiers and things like that, because mainly below 100 decibels, the power requirements are quite modest. But of course, those systems, really struggle when you want to get them to play them loud, right? Now, we have been talking about a 4 ohm 1% efficient speaker in this table here. But what happens when we go and look at some of our other speakers, which are like our subwoofers and our mid bass and things like that, which have much lower efficiencies, 0.1, 0.3, much smaller numbers. So let's have a look at, for example, what happens when we have a less efficient speaker, that's maybe 0.2 instead of 0.5%. So once again, here is the table recut for a 0.2 speaker. So at 100 decibels, instead of needing 1 watt, now I need 5 watts. Instead of being 31 watts worth of energy, I now need 158 watts of electrical power to deal with peaks, and that's 25 volts or 6 amps, right? And of course, as you go up the scale, things get even even more grim, right? So at 110, with a subwoofer, for example, it has a 0.2% efficiency, I'm going to need 1,581 worth of peak wattage just to play at 110, right? And even that's going to be about 80 volts and 20 amps worth of power. So you can quite easily see why, as we start to push up into higher decibel levels, why we need big amps. All right. But speaker manufacturers use the term sensitivity instead of efficiency, right? We don't talk about a 0.2% efficient speaker or a 1% efficient speaker. We talk about a speaker that has a certain sensitivity. And the way they work that out is they measure the loudspeaker from 1 meter away and supply 1 watt of power from the amplifier to the speaker, and then measure the decibel level, right? So, for example, the sensitivity might be expressed as 89 decibels per watt from 1 meter distance away, right? The more sensitive the speaker, the less rigid it is, the easier it is to move with that 1 watt of power. So an insensitive speaker might be 86 decibels, and a very sensitive speaker might be like 93. So this sensitivity of your speakers have a lot to do with the amount of power that you need to supply to your system. So in summary, as you push your system harder, the more power you need, the stronger and tougher your speakers need to be, the bigger your amps need to be, the thicker gauge wiring, a beefier car electrical system in terms of alternators and batteries. And this is why the SPL guys have capacitors and double batteries and zero gauge wires running everywhere and 16 subwoofers and 5,000 watt amps and and all of this type of stuff. And even those guys with all that equipment find it difficult to push beyond 130 decibels, right? So as we covered back at the start of the tutorial, how loud your system will play is going to be dictated by your amps, your speakers that make up your system. So there is a physical limit to how loud you can play your system. Just like a car with a 2-litre engine, it won't go any faster without putting a bigger engine into it, right? So, you're kind of stuck with the system that you've got and the components that you've chosen. So how do you get the most out of your SQ system? Well, there's a big difference between a loud system and one that sounds great and one that sounds terrible and is actually painful to listen to. So we not only wanted to get good volume out of our system, but we want it to be free of distortion and clipping. And so first of all, the very first thing is to have a system that is properly tuned, where everything is playing together, the speakers are summing up to produce more volume, not cancelling each other out. It's a tune that is nice and clear and sounds amazing when you turn it up. You don't want a loud system that sounds loud but is terrible to listen to because it's distorted and it all goes to pieces when you crank it up. Now, one of the myths that I bump into all the time that we need to get out of the way up front is that if you do your tune at 110 decibels or your target, set your target line at 110 or 100 or something, that you'll somehow get a louder system. The level that you tune your system to has nothing to do with how loud your system will be. And I know that it's hard for people to get their head around it. It's a little bit like, people believing that the gain knob, if you turn that up to maximum, you get more volume. People have a hard time wrapping their head around that. But it's tuning above 85 decibels will do nothing else but introduce artifacts and distortion and other problems into your tune. So tune to 85 decibels, that will give you a good clean bass line and allow you enough headroom for peaks and things in your tune. So don't make that newbie mistake that I see new tuners make all the time, and that is to set their target level as high as they possibly can, because they think that somehow that's going to give them a louder sounding system. It doesn't work that way. All right, the second thing that you've got to get right is to set your gains properly, and that's from the head unit through the DSP to all of your amps. Now, when I say set correctly, that doesn't mean turning them all the way up to maximum so that you end up clipping and causing distortion and things. It's about setting your gains correctly so you get the maximum clean output you can get from your system without clipping and distortion. Now, how to do this is covered in the how to set amplifier gains tutorials. You guys should know what the gain knob is for and what happens when you turn up to max, so I won't say anything else about that topic. Third is your routing. Have you wired up your speakers properly to get the most out of them? Can you bridge your subs to get the most out of your amplifier channels? Once again, wiring to maximum output is covered in the wiring subwoofers tutorial. So if you haven't watched that, go check that out. And finally is your source. The choice of your music, the music tracks you play, whether they're FLAC files or MP3s, and how you connect to the DSP, all have a impact on how loud, or more importantly, how loud you perceive your system to be So for example, when things are crisp and clean, the system actually sounds louder than when it does when it's distorted. So use the best, cleanest source that you can. Use FLAC files over MP3s, optical over Bluetooth streaming, even though the difference is extremely tiny now. But the cleaner the source, the less distortion, the less hiss, and the louder things will be perceived in your music. So there you go, guys. That brings us to the end of today's tutorial. I hope that you found that interesting and maybe learned a few things about how sound works and how we perceive loudness in cars and what the decibel scale really is, and more importantly, just how loud is loud, right? I think there's a common misconception, a lot of common misconceptions in car audio, but certainly a couple that we sort of covered today was somehow I need my system to be playing 120 decibels, otherwise it's not loud. That's certainly not true. And I think that if you turned your system up to maximum and recorded it with a sound level meter, you'd just be surprised, what type of result that you're actually getting. Also, there's a difference between having a car that sounds loud and a car that sounds crap when it's loud, right? And a lot of systems that are poorly tuned, or they're just pushing their systems, to the absolute limit, and the speakers are sort of working on their, absolute edge, and they're not able to play properly. People go, oh wow, my car's really loud, but geez, I tell you what, it's painful to listen to because you're pushing it beyond what it can capably do. So if for whatever reason your car is not loud enough, certainly make sure it's tuned and your amps and gains and everything is set properly. That you've got things properly wired up, that you're using a nice clean musical source. And if it's still not loud enough, then you probably need to consider upgrading your amps and maybe speakers, to produce, more acoustical energy, which is the way to get more loudness. But yeah, I hope that this tutorial has helped. Sorry, there's no magic bullet. Maybe you're looking for a secret that people didn't know about to somehow magically make your system twice as loud as it is today. It's just physics, guys, and I hope that we've kind of covered that today. But as always, if you've got questions or comments, please leave them down below. And once again, thanks very much for watching, and I will catch you in the next episode.